We're going to be reviewing combining like terms in a distributive property. Adding and subtracting requires the combination of like terms or items with the same tails, same exact variable and same exact exponent. Adding and subtracting, even though it's easier than multiplying and dividing, they're not very friendly. Whereas multiplying and dividing, you're allowed to multiply and divide everything. They're actually exceptionally friendly. So adding and subtracting, only like other terms that look like them. Multiplying and dividing, you're allowed to do whatever you want. So we're going to go through some examples. I could do a 5x minus a 3x. 5x minus the 3x, they both have the same exact variable or ending, the same exact tail. So I'm allowed to combine them. 5 minus 3, well 5 minus 3 is 2. And then I just drop down the variable. Do not change the variable. Do not make it look like something else. Example 2. If I have a 4x minus 8 minus 6x. So I'm going to see what I can put together. I have a 4x. Does anything else have the same exact ending or tail as this, the same exact variable? The 8 does not, so you cannot combine it with the 4x. But this minus 6x does. And make sure you put the sign that goes, sorry about that, the sign that goes on along with the variable. So I have 4 minus 6, same signs add and keep, they're not the same. So I'm going to subtract. And I'm going to take the sign of the higher, 6 is higher. So I get a negative 2x. And then this 8 cannot be combined, it just drops down. So I have a negative 2x minus 8. You cannot put together the negative 2 and the minus 8 because the negative 2 has an x tail or variable and the 8 does not. So this is the most simplified version that you could possibly have. So I'm going to see what I can combine. This 4 has an x squared term, so I need to combine it with something else that not only has an x, but also has n squared, not just an x. There's nothing else here that has an x and a squared, so this does not get combined with anything else. This 2x has an x at the end. Does anything else have an x at the end? No. So this 2x does not get combined with anything. Drop it down. And this negative 7 and this 6 are the same type of term. They're both just constants. So I have a negative 7 and a positive 6. Negative 7 and positive 6 are different signs. I'm going to subtract and then take the sign of the higher. You cannot put any of these terms together because they have different endings or different tails. The variables are not the same, so you cannot combine them. However, multiplying is very friendly. And let's check this out. I could do a 2x minus 3, 2x minus 3. When I distribute, that's the multiplication process, goes under the m. If we look at our list, it goes under the m. The multiplication, I can distribute to anything inside my parentheses. And when I distribute, it requires multiplication. So 2 times x, well, I'm allowed to multiply anything I want. So I can do 2 times x. Even though this is a number and this one is a variable, 2 times x is 2x. You can multiply anything you want. And then I could do 2 times negative 3. I'm going to multiply that. 2 times negative 3 is a negative 6. Negative 6 is the same thing as a minus 6 when we do these. And then ask yourself, can I put together the 2x and the minus 6? You cannot put together the 2x minus 6 because they're not like terms. And in order to add or subtract these, to combine them, they need to have the same exact ending, and they do not. Our next one. Example 5. I'm going to do a negative 3 times a 4x plus 7 and a minus 1 on the outside. So let's see what we can do. We're not doing P inside the parentheses. They're not like terms. We don't have any exponents, so we're skipping that. We're on multiplication and division. So let's go ahead and see. I do have multiplication here with the distributive property. And like I said, you can multiply anything. So negative 3 times 4x is a negative 12x. Then a negative 3 times a 7, opposite signs, negative 21. And then negative 3 times negative 1. Oh, wait, you can't do that. You cannot multiply or distribute a term from inside or in front of your parentheses to anything outside of your parentheses. Pretend like this is a classroom. Your teacher's handing out worksheets to everyone inside your classroom. This negative 1 is not in your classroom because it's not in the parentheses. That's like in the hallway. Why would your teacher give someone in the hallway the same worksheet that she's giving the rest of you guys? So we're not going to distribute to this negative 1. This negative 1's on the outside, so it just drops down. Now here's a hint. If you have more than 2 terms, you probably are able to smush something together. Like here I had 3 terms, but I couldn't put anything together. Here I have 3 terms. I'm gonna see, can I put anything together? Well, this negative 12x has no buddies. There's nothing else that has an x, so you can't put that together. But here I'm checking out that negative 21 and that negative 1. I can put those together. They're both just numbers. Same signs, so I'm gonna add them and keep the sign. Same signs, add and keep. Do not combine the negative 12 and the negative 22 because they're not like terms. You need to be able to add, subtract these, and you can only do that if they have the same ending. So I want to go over one more type of distributive property problem that I know a lot of people accidentally do incorrectly. So I just want to go over that. And that's when you have a negative outside your parentheses. For instance, if I have a 5 minus a 2x plus 3. A lot of people try to distribute this 5, but this 5 is not touching the parentheses, so you can't distribute it. What we're going to do is we're going to put a number in front of our parentheses that it's a placeholder, but does not change the problem. Usually 0 is a friendly placeholder, but we can't put a 0 here because the times 0 is going to mess up my problem. Anything times 0 is nothing. We don't want to do that. We don't want to cancel out the whole problem. So I'm actually going to put a times negative 1 out front. When I do that, I'm able to distribute. A negative 1 times a 2x is a negative 2x. And then a negative 1 times a 3, my marker is dying. Negative 1 times a 3 is a negative 3. This 5 I didn't use, so we're just going to drop it down. Don't forget about that 5. 5 is still an important part of the problem. Now I have 3 terms. Sometimes you can clean it up, sometimes you can't. In this case, we definitely can. So let's see what is going to be able to be smushed together. I have a minus 5. Sorry, a plus 5. Is there anything else there that is just a number? Yes, I have a minus 3 here. 5 minus 3 is 2. Has always been 2. Will always be 2. You can also say that they're opposite signs, so I'm going to subtract and take the sign of the higher. This 2x has no buddies, so we're not going to combine it. Now, this is a good answer. This is a good answer, but it's not a great answer. We're going to be talking about the difference between good and great answers, and what makes this a great answer is by putting the term with your letter, with your variable first, and the term that doesn't have a variable, just a number, goes in the back. That's what we call a constant. And I like to say it's constantly alone. Doesn't have anything to hang out with back there. And it's constantly in the back. This is a great answer. Ooh, there you go. A great answer. All right.